Hello everyone. In today's lesson we will be studying Euler method for solving differential equations, which is a topic in the IB Math AA high level. First, we'll understand this formula here, which is given in the formula booklet, and after that we'll solve this example using the formula. And of course we'll show the solution step by step in the GDC here in front of you, the TI Inspire. So first, this is the formula for Euler method. H here is the step size, which is in our example here 0.1. Here we have an important component, which is f of xn, yn, or f of xy. By definition, f of xy is equal to the derivative in the differential equation. dy over dx is equal to fxy. Which means first you have to write the differential equation like this first. You notice that in our example dy over dx is multiplied by x, but we shouldn't have x. That's why we have to divide by this x to eliminate it and send it down with this x, so this x will be x squared. So here we'll have, if we divide by x, dy over dx will be 3 minus y divided by x squared. Next, now you see that here we have the iteration for x. It means each value of x is equal to the previous value plus the step size h, which is 0.1 in our example. So I write it now. xn plus 1 is equal to xn plus 0.1. Similarly now, here we have yn plus 1 equals yn, or the previous y, plus the step size h, which is 0.1, multiplied by f of xn, yn. Now see here, f of xy is equal to the derivative. In our case, the derivative is this. So this is here f of xy. I will write it now here, but I will replace the x and y by xn and yn. So we'll have now, instead of 3 minus y, I will write it 3 minus yn. Instead of x squared down, it will be xn squared. Now, of course, you don't have to write these in the solutions, but I wrote them here to explain how we'll enter them now in the GDC. But first, finally here, in Euler method, you will be always given a point, an initial point on the solution here. X is 1, when x is 1, y is 2, which means x0, we write it like this, the initial value of x0, 1, and in that case, y will be 2. We label them like this, x0, y0, as we'll see now in the GDC. So first, to solve it in the calculator, as you see, first we open a spreadsheet now, and after that, I will label here 3 columns. We'll explain them one by one. The first one will be for n. The second one will be for xn, and here for yn. Now labeling these, these labelings are also optional, but it's better to label them to tell you like which column is which. You don't have to write xn plus 1, just xn to indicate that this is for the x's and the next one for the y's. Now what is n? We'll see. First we enter 0, and then here 1. Now of course, everything I'm doing in this GDC can be done in the same way in the physical calculator. You can fill these manually one by one, but also to practice the GDC more, we can do it like this. We can select this. Now we select menu. First we have to select the other one now. So first we press the shift button and then select down like this. As you see, it selects 1. After that we do menu, then data, fill. As you see, we press the down button up to 6. So here n will be up to 5, as you see, from 0 to 5. Now why did I stop at 5? Because here, look, the initial value of x is 1. We need to find the solution when x is 1.5. So we have to go from 1 to 1.5 with steps of 0.1, like 1.1, 1.2, 1.3. From 1 to 1.5, you need 5 steps. That's why here n, we needed to stop at 5. What is n then? Here, for example, as you see, n is 0, which means this will be here x0, x1, x2, x3, and so on. Here y0, y1, and so on. As you see, x0 and y0 are the initial values given, 1 and 2. So I will enter here 1, and here I will put 2. Now, first we'll fill in this x. We can do here 1.1, then 1.2, but to practice the GDC, I'll do it here quickly in 2 ways. First, I can do in the same way as we did the n column, so 1.1, and then here I press Shift, Select, and then Menu, Data, Fill. Then we scroll down. Here we scroll down like this. Then press Enter. As you see, x is up to 1.5, which is what we need here. Another way, which is more important now to do, especially later for the y column, you could do it like this. First, we press equal to start the code. Now, as you see here, each value of x is equal to the previous x plus 0.1. So here, each value of x will be the previous x. Now, the previous x will be here in the previous cell, which is, as you see, B, column B, and row 1. It's labeled like this, B1, in the cell B1 above, plus the step size, which is 0.1. And then we press Enter. As you see, we got the same value. Then what we can do, we press only on this, on the coded one. Now we press Menu, Data, and then Fill. As you see, we can press this, the down button here, like this, up to 5, enough. As you see, again, 1.5. The same way now will follow in the y column, which is now the most important column. It will be the one that gives us the solution. As you see here, we will enter all of this in the GDC. Each y will be the previous y plus these. So I will write also equal first. So first here, as you see, the previous y. So the previous value of y, which is here too, in the cell C, column C, row 1. So I write C1. Then we have plus, as you see. So we have plus 0.1 multiplied by, then we'll open a fraction, control and then division, because you see here we have a fraction. First we have 3 minus, here as you see we have yn, which is the same y here, the y in the previous cell. So I will write now cell C1 as it is, divided by, here as you see in the denominator we have xn squared. So the previous x squared, the same x we used here, which is x in this B1 cell. So I will write B1 and then here. So we can write it like this in the keyboard of the calculator, as you see, B and then 1 squared. And then we press Enter. As you see, we got 2.1. So to fill the others, automatically we'll do the same. Now we do Menu, then Data, Fill, and then we press down button like this, up to this here, enough. So as you see, these are the iterations for y, or the solutions here. What we need from this is this. As you see from the table, when x is 1.5, y will be 2.31. So this is here the solution. We can write the whole table like this. Here, I copied the same table from the GDC, but the values of y are rounded now here to 3 significant figures. What we need here, what we need is this. When x is 1.5, y, as you see, 2.31. So this is the final answer. This is the solution when x is equal to 1.5. This is the value of y, the approximated value of y. I hope that you have found this explanation helpful. Please hit the like button and consider subscribing to the channel for more videos. Thank you for watching.